Welcome to this explainer. You know, everything you probably learned in school about the early universe, well, it's basically being rewritten right before our eyes. Today, we're exploring a massive paradigm shift in astrophysics. We're looking at a marvel of modern engineering that is quite literally acting as a time machine, and it's completely upending our understanding of the universe and our cosmic origins. So let's just dive right into the deep end here. Looking back 13.4 billion years, is that even possible? Take a second to really let that number sink in. To understand our cosmic origins, we have to find a way to look back to the very beginning, to see the universe as it was just after the Big Bang. But how do you actually peer into the past? Well, the only way to do it is to capture ancient light that's been traveling across the absolute void of the cosmos for billions of years before finally hitting a lens. And the solution to this seemingly impossible task? It's the James Webb Space Telescope, or JWST. Launched back in 2021, this thing isn't just floating around in low Earth orbit. It's parked at a specific gravitational sweet spot called L2. That is a staggering 1 million miles away from Earth. Out there in absolute freezing isolation, its primary job is to detect the very first stars to ever ignite. Let's move to Section 1, Seeing the Invisible, the Infrared Solution. Now, you might be wondering, why go through all the trouble of building a completely new telescope when we already had Hubble giving us those iconic images for decades? Well, visible light just isn't going to cut it for this extreme kind of time travel. Visible light has tight wavelengths that just bounce right off dense cosmic dust, which completely hides early star formation from view. The longer wavelengths of infrared light, however, slip right past that dust. It's like having X-ray vision for the cosmos. Plus, it allows us to catch ancient light that has been physically stretched out over eons. Astrophysicists call this stretching process cosmological redshifting, and it is absolutely crucial to understand. Basically, as the universe expands, light from those early stars, which was originally emitted in visible or ultraviolet wavelengths, is physically stretched into the longer wavelengths of infrared light over billions of years. This is exactly why JWST's primary instrument, the Near-Infrared Camera, or NICAM, is the ultimate time-traveling tool. It's purpose-built to see light that's been stretched to the very edges of the spectrum. But here's the catch. Capturing these unbelievably faint, stretched-out signals is exceptionally tough. I mean, any background heat from the telescope itself would completely wash out these ancient whispers of light. So to prevent this, the engineering team had to design NICAM to operate near absolute zero. We're talking 0 Kelvin. That freezing vacuum of space, a million miles away at L2, actually provides the perfect, brutal environment to keep this highly sensitive equipment cold enough to work its magic. Which brings us to Section 2, GNZ11, the ancient black hole. Let's look at the first major clue uncovered by this time machine. It's a high-redshift galaxy known as GNZ11, and this brilliantly illustrates the mind-bending scale we're dealing with here. The light from GNZ11 was emitted 13.4 billion years ago. For context, the Big Bang itself was 13.8 billion years ago. So we are seeing this galaxy exactly as it looked just 400 million years after the dawn of time itself. And because the universe has been expanding that entire time, the actual physical distance to this galaxy today is a wild 32 billion light-years. To really put this into perspective, let's compare GNZ11 to our own home. It is tiny compared to the Milky Way, just 1/25th the size and about 1% of the mass. But do not let its size fool you. It is churning out new stars at a completely frantic pace, roughly 20 times faster than the Milky Way does today. We're looking at a chaotic, hyperactive environment straight from the dawn of the cosmos. But the absolute most crucial point here is what JWST actually found hiding inside it. In 2024, data revealed that GNZ11 contains a massively huge black hole, estimated at 1.6 million solar masses. That makes it the earliest and most distant black hole ever known to science. Finding a black hole this massive, this early in the universe's timeline, just completely shatters what we thought we knew about how these cosmic voids form. According to all our established models, it simply should not have had the time to get that big. No way. All right, moving on to Section 3, Enter the Red Monsters. Because honestly, GNC11 was just the warm-up act. JWST's FRESCO program, which uses that NIRCam spectrograph to measure incredibly accurate distances and stellar masses, was about to uncover something that literally defies our astrophysics textbooks. Check these out. The three red monsters. These are ultramassive galaxies that somehow formed within the very first billion years of cosmic history. They glow this fierce red color because they're packed with heavy dust, which means without JWST's specific infrared capabilities, these monsters would still be completely invisible to us. To understand why astrophysicists are so completely shocked by this, you have to look at the standard models we've relied on for decades. We believed early galaxies formed gradually. The idea was that dark matter halos captured gas and then converted at most about 20% of that gas into stars. But the reality observed in these red monsters, star formation is nearly twice as efficient. They are growing at unexpected, blinding speeds that completely break our current models. As Dr. Mengyuan Shao, the lead author of the study from the University of Geneva, puts it, our findings are reshaping our understanding of galaxy formation. Finding galaxies this massive, behaving this efficiently, and this early in the timeline, it means we aren't just slightly tweaking our models here. We are missing a massive piece of the puzzle entirely. Which leads us perfectly into Section 4, breaking the rules of cosmology. So why exactly are these red monsters such massive rule breakers? Well, first off, they exist way too early, within the first 1 billion years post-Big Bang. Second, their stellar masses are already comparable to our fully grown Milky Way. And third, this rapid, hyper-efficient growth completely contradicts the long-held gradual formation model. To put it simply, we are spotting cosmic toddlers that already weigh as much as full-grown adults. It's a complete shock to the system. These galaxies grew too fast, too soon, and we currently have zero established physics to explain exactly how they pulled it off. Dr. David Elbaz, director of research at CEA Parasocle, really hits the nail on the head here. He points out that the massive properties of these galaxies were basically unknown before JWST because they are optically invisible due to dust attenuation. Past telescopes simply couldn't see them. This proves exactly why JWST wasn't just a nice upgrade, it was a strictly necessary leap forward. We literally had to build a brand new type of eye to see what the universe was hiding in the dark. And you know what the most exciting part of all this is? This single discovery strongly implies there could be a whole hidden population of these absolute giants out there. Future observations partnering JWST with the ALMA radio telescopes are going to hunt for more of these ultramassive anomalies. We are watching scientists worldwide be forced to rethink the unique processes that shaped the earliest epochs of our reality. Science is an active, ongoing process, folks, and we are right there on the absolute frontier. Which leaves us with this final, really mind-boggling thought to ponder. If a single new piece of tech can completely rewrite our understanding of how galaxies and black holes are born after just a couple of years of operation, we have to ask ourselves, what other massive secrets are still waiting out there in the invisible light? Thank you so much for joining me on this explainer today, and as always, keep looking up.